Hello, professor. So this is a quick video talking about lab number 6. So for the first experiment, we will be using an array, and this is on a stepper motor, so we'll be using 2 bytes at the same time. So the way this is done is we take this, these are steps, and these is kind of like our poles, and then if we convert this into binary, it's 1100, 0110, and so on and so on, and then we convert these into hex, and we can use that in our code. So moving quickly to our code, talking about example or experiment 1, we will be addressing the mask for the 4 pins we will be using. We have to shift our bits 4 times, and then this is what we do. So this is some of the math behind our steps. So if we want to move 120 degrees, we need to move 682 steps, here being clockwise and here being counterclockwise. Here's our set of GPIO. Now, in your website, I talked about converting our 4 steps from binary to hex, and this is where each step comes up, and we create an array with 4 elements, and our 4 elements are that in hex. Now, this is where the code comes up for the array, right here. So in short, what it's saying is we have an integer I and a static integer I dx, or index, which is equal to 0, is initialized to 0, and then I is initialized to 0. So what this is in short saying is, while I, this integer, is less than s, if the direction is going clockwise, we increment our index. If we're going counterclockwise, we decrement our index. Now, if our index is less than 0, we're going to update our index. Our index is going to be the size of the steps, the array, right, divided by the size of the first element minus 1. Now, if our index is greater than or equal to 0, we take the size of our steps, the array, and divided by the first element of the array, and we say it's 0. We update our index to 0. Now, this is a pointer to what our element is here. So instead of moving it to the 4 steps, we're going to pick this one and then again shift our bits 4 times, delay 10 seconds, and continue going. And I will talk about the next one really quick. I want to make this video too long. So this one here is using a Mealy step machine. In short, everything up here is the same, so I will skip this and just go to the Mealy state machine. So here we create the 4 states. Here we create the 4 stepper values, and I commented out just because I wanted to ensure that I had it in for notes. Right, in short, we have a pointer pointing at this one and shifting it 4 bits. I forget if we're using the upper 4 or the lower 4 bits, but we're using the incorrect one, so we need to shift it. Okay. In short, we up here made our 4 cases. Now, if we're in case 1, if we're going clockwise, what we want to do is change to our second phase, and this is what gets us there. So it's probably easier to show you the picture and to keep going. So let's do that. So in short, if we're here and we're going clockwise, so we're going to move to state 2, and to do that we need to use the pointer, which is going to get us there. And we do that. And the opposite way around is if we're here and we want to go counterclockwise, we would go this way to step 4 and this way to state 3, 2, and 1. And to go from 1 to 4, we need a pointer that's going to get us to state 4, and so on and so on. Now, our last one is using a double linked list, which it's here. And here we create a structure, which is our pre, our data, and then our next. Here we do exactly that, and I'm going to show you that here. for our linked list. So our pre is at 7. Hold on. Here. So our pre was at 7, or the 7th step, right? Because we have 8 steps, but it's 0, 1, 2, 3, 4, 5, 6, and 7, and we go so on and so on. So pre, then data, then the next one is going to be element 1 of the double linked list, and so on and so on. So then I have a couple errors in my code that this one in particular doesn't quite work yet. I know I'm very close, but it doesn't quite work. So I had an appointment for 7 p.m. on Friday for the code, but things happened, so we weren't able to meet. And yeah, so I'll be getting this code, but I'll be submitting this project like this. Thank you so much, Professor.